Everybody, Dr. Marty back here. We're now into chapter 5 of our notes in algebra. And this chapter is on lines and linear functions, and we're going to start by learning about slope. So, first of all, there are different types of slope, and we're going to be investigating how to find slope in a little bit. Before we get there, let's just look at actual types of slope and what it means, okay? So first of all, if the slope is going up as it goes to the right, we're looking at as it goes to the right, if the slope of the line goes up, this is going to be a positive slope. If you've seen the ski dude video, puff, puff, positive, because when you're going up, you got to puff. So positive slope up and to the right, okay? If we're going down as we go to the right, this is going to be negative. Negative, okay? If we have a horizontal line, that means as we go to the right, the slope doesn't go up or down. Sorry, the line doesn't go up or down. This is a zero slope. And m represents slope, so m equals 0 here. And then, if we have a situation where our line is vertical, straight vertical, up and down, okay? It means the x is not changing. This is undefined slope. We're going to see why in a little bit. Okay, so if we're going up as we go to the right, positive slope, down as we go to the right, negative slope. If we're going straight, not going up or down as we go to the right, it's a 0 slope. And if we're going straight down or straight up, right, that is undefined. Okay, now when we try to find slope, okay, there are a couple different ways that we can do it. And we're going to practice all three. It's all using the same concept, but the equation for slope is the change in y. So you have points on a graph, right? So we're seeing how y changes over how x changes. It's also sometimes referred to as rise over run. Rise is the change in the y direction, so up or down. Run is the change in the x direction, right or left, okay? So the easiest way to solve for slope is to have 2 points that are on the line, and to take the second y value and subtract the first y value on top, take the second x value and subtract the first x value on the bottom. Divide those out, that gives you your slope, okay? But we're going to investigate a few different ways that we can find slope. The first is looking at a table. So sometimes you're given a table of numbers of x and y values, coordinates, right? And what you can do is you can check to see if the rate of change is constant. That means how they change from x and how they change from y. If it is, then you can find the rate of change just by looking at how the change in y is over the change of x. So let's do an example, okay? On the x here, we have 3, 5, 7, 9, 11. So what happens is we increase by 2, plus 2, every time we move down the table, okay? And then with the y, we're increasing by 5. 5 to 10, 10 to 15, 15 to 20, 20 to 25. So we're going plus 5, plus 5, plus 5. Okay? So this is going to give us a slope m. Try to use color so this is clear. Okay? M is going to be the change in y over the change in x. Well, we know that every time we move from one row to the next, we're going up 5, right? So we have plus 5 on the top. In the x, we're going up 2, so plus 2. So we end up getting an answer of m equals 5/2. It's positive, okay? Let's look at this next one. We have on the x side, 4, 9, 11, 15, 18. So this 4 to 9 is plus 5, 9 to 11 is plus 2, 11 to 15 is plus 4, 15 to 18 is plus 3. On the y side, 6 to 12 is plus 6, 12 to 18 plus 6, 18 to 24 plus 6, 24 to 30 is plus 6. Now, this one's a little bit tricky because the y values are increasing by a regular amount, plus 6, but the x values are not. So between 4 and 9, the x goes by 5 and the y goes by 6, but between 9 and 11, the x goes by 2 as opposed to 5, and the y still goes by 6. This means that the rate of change is not constant. So there's no constant rate of change What this means is this is not a line. Not a line, okay? So that means you can't find the slope because it's not actually a line, right? Then finally, let's look at this one down at the bottom. I'm going to slide it up into the screen so we can all see it. We got 1, 2, 3, 4, 5, 6 over here. I think it's pretty easy to see that we're adding by adding 1 each time as we move down in the x. Over here we've got 10, 8, 6, 4, 2. We're subtracting 2. Negative 2, negative 2, negative 2, negative 2. So our m value, our slope, equals change in y, which is going to be minus 2, negative 2, over change in x, which is positive 1. Well, we know that negative 2 divided by positive 1 equals negative 2, and that's our slope. Okay, so that's how we find slope using a table. Let's try the two other ways now. Second, let's look at finding slope when we're given 2 points. 2 points. So here we have our equation again. M, the slope, equals y2 minus y1 over x2 minus x1. All right. So example 1 is we have 2 points, 4, 5, and 3, 2. Now I'm going to use the same colors. I'm going to say that this is x1, this is x2. So these are points 1, points 2. This is an x, sorry. And then this is y1, and this is y2. All right. So our slope m is going to equal y2 minus y1 over x2 minus x1, right? That's just our basic equation. Sorry, this is moving around a little bit. So that means we get on top y2, which is 2, better use the right color, minus y1, which is 5. And on the bottom, we're going to have x2, which is 3, minus x1, which is 4. All right, that's going to give us negative 3 on top, and on the bottom, negative 1. Well, negative 3 divided by negative 1, I think we know, is going to be positive 3. So our m equals 3. Okay. Let's do the same thing over here. Example 2, negative 5, 7, negative 2 over 4. M equals, I'm going to draw these out just to make my life a little bit easier. Now I'm not going to write out y2 and y1. We know that. y2 is 4 minus y1, which is 7. x2 is negative 2 minus x1 is negative 5. Now it's going to be minus negative 5. Does everybody see that? Okay. So when we go through, we get negative 3 up top. 4 minus 7 is negative 3. Negative 2 minus negative 5 is positive 3 on the bottom. Okay. So m equals negative 3 over positive 3, or negative 1. So that's how you can use 2 points to find the slope. Okay. Then finally, you can find the slope using a graph. Okay. So here's some examples, and I'm going to zoom in a little bit to make sure you can see what I'm doing. There we go. Okay. So when we're trying to find the slope using a graph, what we can do is we need to find 2 points, and we're going to see how the y moves with relation to the x. Now, one little trick for this is it's helpful if you use points that actually cross at an x and a y. So for example, I could pick a point right here, but it's hard because then you're working with halves. Or I could pick a point here. So I'm going to pick this point because I see it crosses the x-axis there. I'm going to pick this point because I see it's a nice clean point at 1, 2. Okay? At 1, 2. So this is at negative 2, 0, and this is at positive 1, 2. All right. Now, remember, slope m is change in y over change in x. So there's a couple different ways we can do it. I'm going to start by showing you, just looking at the graph. So what I'm going to do is I'm going to see how far we have to go to get up to the y value up here. Well, this is plus 2, right? It went from 0 to 2. Then I'm going to see how far we have to go to the x value. 1, 2, 3. So plus 3. So our slope, m, is going to equal, this up, okay? It's going to equal positive 2 over positive 3, right? For every 2 that it goes up, plus 2, it goes 3 to the right. So our slope is 2/3. Now, just to be just to be consistent, let's check it. All right. So let's say that this is point number 2. This is point number 1. So m equals. I'm not going to use different colors this time, but I think you know how to do this. y2, which is 2, minus y1, which is 0, over x2, which is 1, minus x2, which is minus x1. This is x2. This is x1. Negative 2. And that gives us 2 minus 0, which is 2. 1 minus negative 2, which is 3, or 2/3. So we have the same thing. Okay. All right. Example number 2. We've got 2 points right here. So let's just see. We're going down 1, so negative 1. We're going over 1, 2, 3, positive 3. Okay. So our slope m is going to equal negative 1 over positive 3. So that's going to give us negative 1/3. So how could we calculate this slope using our 2-point way? We've got 2 points here. We've got negative 1, negative 1. And we've got 2, negative 2. So x2, y2, 2, negative 2, x1, y1, negative 1, negative 1. So we get m equals negative 2 minus negative 1 all over 2 minus negative 1, which is going to give us negative 2 minus negative 1 is going to give us negative 1. 2 minus negative 1 is going to give us 3. So that's negative 1/3. Okay? And then finally, example number 3. I think we get the point now, but let's just do it again. We have 2 points. This point is at 1, 2, 3, so 0, negative 3. This point is at 1, 2, so 2, 0. So our y value changes by 1, 2, 3. That's 3. Our x value changes by positive 2. So we get m equals positive 3 over positive 2, or 3/2. And we can check it again. M equals 0 minus negative 3 all over 2 minus 0, which is 3/2. So that's how we can calculate slope. 3 different ways to do it. Usually we'll be calculating slope using this method, where we'll have 2 points. That tends to be the easiest and most consistently able to be done. But there are certain times when all 3 of those can come in handy. All right, that's it for today. I'll be back in the next video to talk about slope-intercept form. Yeah.